This is my Cowell 90 ME lathe. I have some accessories shown here. The lathe has a solid cast iron lathe bed. It sits on an aluminum base. The motor is to the rear, sits under the table. We have forward on-off switch here. This is in forward. This turns it on. That's to stop. And this gives you reverse. In the middle, it's off. Won't move. There's a cover. The motor has 2 speeds because it has 2 pulleys. We have 3 pulleys on the headstock, which gives you 6 speeds in direct drive. We have a back gear, which gives you an additional 6 speeds for back gear. This is the auto traverse unit. When it's engaged with this dog clutch, it will move the saddle either towards the headstock, or if you reverse the motor, it will move it back out. We have a tailstock, which can be set over for taper turning. There's a compound. So I'm going to turn it on. I have it in back gear, set for 180 RPM. Since this is a USA machine, which operates on 60 HZ, the speeds will be increased by 20%. In Europe, and I believe most of the world, it's 50 HZ. So whatever these speeds say here, you will actually increase those by 20%. I'm going to turn it on. We're going to have 10 gears running here, steel gears. 1, 2, 3, 4 for the back gear. For the auto traverse unit, we have 1, 2, 3, 4, 5, 6. So a total of 6 gears will be running here. It will be a little bit noisy. Since there's no load, it's not cutting anything. Move the saddle out a little bit. And engage the auto traverse unit. You can see the hand wheel for the lead screw is turning. The saddle is advancing towards the headstock. And the trip lever is approaching the bar, and it's slightly moving. When it gets right about vertical, it will stop. Trip bar screw as supplied. Trip bar screw as improved.
you disengage auto feed, it's easier to remove the small top gear than to drop all of the gears at once. Facing cast iron using a 5/16 2-bit mounted directly on the compound. Back gear is engaged. Turning cast iron is a bit messy. My lathe was due for cleaning about this time. Using a T-nut is sold by Cowell, I made a mount. My dial test indicator is shown in the rear. Drilling to 1/4 inch. A small brass collar to the rear of the drill chuck was made to prevent the drill chuck from being injected when I would bring it to the rear. It's also useful to measure the movement of the tailstock. No. I first use a small barn ball with a minimum diameter of 3/16 inch. Then I switch to a larger barn ball to finish it to the 3/8 inch inside diameter. A 1-inch square block was used to make the gauge. I milled one end down to .995 and placed the top piece with a shim under to get it to the correct height. A 3/8 rod was milled down with a nut on the bottom to fit between the slots in the faceplate.
Using the faceplate as a driving plate, I am turning a long rod between centers using the feed.
The SHERLINE is threaded 3/4 inch by 16. I made an adapter plate with a locking ring. The spindle nose is threaded 14 millimeter by 1 inch pitch. SHERLINE now sells a 4-jaw chuck with the 14 millimeter times 1 millimeter pitch spindle nose thread.